only visible with a password. Okay, good. Sorry for interrupting.
Thank you, Daniel. Thanks. This is a very important point. Now I'll go to introducing Dr. Thomas Heege. Thomas Heege is the Managing Director of EOMAP, headquartered in Germany. He has more than 25 years of experience in aquatic remote sensing and environmental data services for water-related industries and agencies worldwide. Under his leadership, EOMAP developed the technologies and marketed for space-based high-resolution bathymetry, which is a very important topic nowadays, how to get remote sensing bathymetry, water quality, and environmental aquatic services as well. Prior to founding EOMAP in 2006, Thomas was a research scientist in German Space Agency, DLR, since 1996. He had developed physics-based processes for aquatic systems using multispectral and hyperspectral airborne sensors. He worked as a researcher at Hydrological Limno Institute in Konstanz at Munich in a range of multidisciplinary projects on applied biooptics and remote sensing. He graduated as a physicist in 1993 at the University of Konstanz and received the PhD in space sciences in 2000 at the Free University of Berlin. So I have a moderator for this session, Mr. Murali. Professor Murali. Sorry for that. I'm from the government meeting. I just came out from the government meeting. That's why that impact is still there for me. And I also wanted to introduce Professor Murali, who is the head of the Department of Ocean Engineering and also professor in charge of National Technology Center for Ports, Waterways and Coasts, IIT Madras. He received the PhD degree in hydrodynamics of floating breakwaters in 1997 from IIT Madras. His research focus area are coastal and ocean dynamics, sediment transport and dredging, and also multi-phase flow simulations and general free surface flows. He was instrumental in establishing the National Technology Center for Ports, Waterways and Coasts, through which scientific and technological studies being carried out and implemented in ports and waterways to enhance the productivity to develop the world-class ports and waterways. I wanted to give this line because so that it will fit into this today's topic. That's why. Thank you.
Okay.
Thank you. With this, I invite Professor Murali for the moderation.
Okay. Good afternoon. Good evening. All of you. So now we get on with the panel discussions. And first up, I would invite Professor Strunz to start his introduction.
Yeah. So first of all, good afternoon or good evening.
Coming from your side. Dr. Raju, there is echo coming from your side.
I'm sorry, I have so much echoes, so please mute your microphones. Now it's better. Okay.
Yeah.
Good. Yeah. So good afternoon or good evening to the colleagues here in India. I'm very pleased to be here in this panel session. And I've prepared some slides to introduce the topic. So let me just. Can you see my slides?
Perfectly.
Yeah. Okay. Well, what I would like to introduce is the topic on Earth observation and artificial intelligence for flood monitoring. Well, generally speaking, when we talk about flood monitoring or in general disaster management, we talk about this disaster management cycle. So we have a pre-disaster phase where we do a risk assessment and mitigation and prevention of disasters. Then we have an early warning phase, the emergency response phase, and the post-disaster phase. And Earth observation can contribute to all these four phases. So think about the risk analysis. We can provide information about the assets and the people which are in hazardous areas. So we can contribute to the exposure in the risk analysis. We can contribute to early warning. Think about cyclones or hurricanes, which we can see, which we can monitor from low resolution Earth observation data. And then, of course, very important, the emergency response phase, where we can provide information which is needed very, very quickly, and where we do a rapid mapping to show the effects of a disaster. And finally, the reconstruction, where we can monitor how everything is built back and rebuilt. Focusing on the emergency response, there is an important agreement between the space agencies to provide, in case of major disasters, contributions by Earth observation. So this is called the International Charter Space and Major Disasters. It's an agreement which is now operational since more than 20 years. So it provides a system that this system provides the access to the space data from the different member states. And here you see the member states. So currently we have 15 or 16 members of a charter. And what you see here is ISRO, the Indian Space Research Organization, is also partner of this international charter. We have other partners like the French CNES, then we have the European Space Agency, we have the Americans USGS and NOAA, we have a Japanese JAXA and so on, and DLR is also member of it. And the system has several roles, and the charter can be activated by so-called authorized users. And this is normally a governmental organization, normally a civil protection agency or a foreign ministry of a country. So in your case, in India, it's ISRO or it's the Civil Protection Agency. And then each space member agency has committed satellite resources to support the charter. So they provide their own satellites, they do the tasking of the satellites and provide this in case of an activation of a charter. So what we get is really an agreement which provides satellite data as fast as possible in case of an emergency. And you see here what the charter is covering. It supports emergency response immediately after major disasters. So we're talking about natural disasters like storms, floods, landslides, wildfires, earthquakes, and so on, but also man-made disasters. So for instance, large industrial accidents or oil spills, which are man-made disasters. The slow onset disasters like the droughts are not covered by the charter. The charter is available around the clock, so it's 24 hours, 7 days a week. And the members of the charter have committed that they task their satellites with very high priority. So this is something which is ensured by the members of the charter. And an activation in general lasts for about 1 to 4 weeks. It can be also activated in advance, 1 or 2 days, if, for instance, it's already very probable that, for instance, a hurricane is approaching, and then the charter can be activated 1 or 2 days in advance. And here you see an overview of the activation. So we have more than 600 activations so far in more than 120 countries. And what you see here is the most frequent disaster, which is covered by the charter, are the floods. You see here around 50% or almost 50% of the activations of a charter are due to floods. We also have, of course, activations due to earthquakes, to landslides, to fires, to storms and hurricanes, and so on. But again, flood is the most frequent disaster where the charter is activated. And just to give you an idea for the recent activations in India. So we had in February, beginning of February this year, we had an activation for the flood in Dhauli Ganga River. We had in 2025 activations, so 2 cyclones, the cyclone Nivar and the cyclone Amphan, where the charter was activated, and we had the floods in Kerala, in Bihar, and in Assam, where the charter was activated over areas in India, and 3 activations in 2019. So again, for floods, cyclones, and the same in 2018 cyclones, landslides, and floods. So it has proven a really very reliable and operational mechanism where the information is provided to these authorized users in the different countries. And this is just an example. This is a map that we have produced for the activation in Assam in July last year. So this is how a map typically looks like. You see in dark blue the normal area where the river is situated, and then in light blue you see the flooded areas, and we have overlaid this also with information about the population distribution, so that you can see how many people are affected by the flooding. So this is a typical map that we have produced in the framework of an activation of a charter and provided it to the charter. So this is an international mechanism. What is also important is what's going on in Europe. In Europe, we have Copernicus, that is the European Earth Observation Programme. And within this Copernicus program, we have so-called Sentinel missions. It's a series of satellite missions, and you see it listed here. So we have Sentinel-1. This is a radar mission. Currently, 2 satellites are in orbit, Sentinel-1A and 1B. And as I said, it's a radar mission. So we have the advantage that you can see through the clouds. You can do data acquisition during day and night. And this is, of course, very important when you're talking about flood mapping. So we have 2 satellites in orbit. Sentinel-2 is a high-resolution optical mission with 10 or 20 meter geometric resolution. Currently also 2 satellites in orbit. So we have a revisit time of every 5 to 6 days globally. So really also a high repetition rate. The same is true for Sentinel-1. And with Sentinel-3, we have a medium resolution imaging and altimetry mission. Also 2 satellites in orbit. So as I said, lower resolution, but of course a very large coverage. And here we get a coverage of every 1 to 2 days globally. And what is very important for the Sentinel missions is the data policy, and the access to the Sentinel data is free and open. So everyone worldwide can have access to this data and can use the data for their own purposes. It's not restricted to scientific applications. All applications are possible. So there are no restrictions on the use. You can reproduce, you can use it for commercial or non-commercial purposes. And as I said, it's free of charge data licenses. So very interesting data set, especially when we're talking about flood monitoring or water monitoring. And here are some figures. So the Sentinel data can be accessed by this so-called, you see it on the left side, the Copernicus Open Access Hub, where all the Sentinel data are freely available, can be downloaded. And you see on the right-hand side, the Open Access Hub currently has almost 300,000 registered users. And just to give you a figure, the Sentinel missions provide around 15 terabyte per day of data, which are transmitted to the ground station. So really a large amount of data which are freely available and can be used. And now what we see within the last few years is really a paradigm shift, because we now have the techniques of artificial intelligence, which we can combine and use for the analysis of Earth observation data. And why is this so important? Well, first of all, we see a substantial increase in Earth observation missions. We have a governmental missions, as already mentioned, like the Landsat program, the Copernicus program, but we also have commercial operators. Like the new space companies, which pop up every few months, announcing new missions, new mission concepts. We have an increasing revisit frequency and higher spatial resolution. And we have, on the one hand side, continuous data acquisition or very flexible systems where the satellites can be tasked to take data on demand. And as I said, it's really a boosting area where we are currently think about the planet scope satellites, where we have around 150 satellites, CubeSats in orbit, which provide daily information about the Earth. And as already mentioned, the Copernicus program, very important with its free and open data policy. Not only the Earth observation data are increasing massively, we also have new data sources. So open source data like OpenStreetMap, which are more and more available, which can be combined with our Earth observation data, or a large amount of information is provided by volunteers. So volunteers are providing geographic information which we also can use in case of disasters. And what is also important, the social media. So a large amount of information comes from the users of social media, which we can harvest, which we can, in case of an emergency, can select and can get information from this huge amount of social media data and social media images. And we have new opportunities now using artificial intelligence. So just very, very briefly spoken, on the left-hand side, you see, I would say, the classical approach. We have developed methods and algorithms which are based on rules for instance, flood mapping. And now we are more and more training neural networks, convolutional neural networks, using learning from the classical physical models, and using this large amount of available data as a reference and a training source. And what we are currently building up is a database, a global reference database, where we use Sentinel-1, Sentinel-2 data, but also very high resolution optical data to build up a global reference database where we can train our new developments, our neural networks applying artificial intelligence. And the results are really very promising. So we have overall accuracies for water and land classification, which are better than 90%. And this is my final slide. So what is the outlook? The outlook is global flood monitoring. Well, currently, as I already mentioned, we are a bit delayed in case of flood mapping. So normally what is happening, we have an authorized user, he is activating a mechanism like the charter, and then we do the tasking of the satellites, and then we download the data, we receive the data, we do the processing, and this takes time. And the new idea now behind that is, well, let's systematically process all Sentinel data, all Sentinel-1 data worldwide. So every Sentinel scene which is acquired, which is permanently, continuously being acquired, and these are more than 1,000 scenes per day, are being processed automatically. So you don't have to interact, you don't have to activate a processing chain. And that leads to a continuous monitoring of floods in almost near real time. So the goal is that within 8 to 12 hours after the sensing, we will provide data about the flooded areas to the users worldwide. And by that, we also build up a global archive of flooded areas. So we are working on that in a consortium within the Copernicus program, and we will start with this global flood monitoring in autumn this year. Well, this was a very short, I would say, introduction to give you a short insight into flood monitoring and how we can use artificial intelligence and what are the future trends in that field. So thank you very much.
Thank you, Professor Strunz. Dr. Raju, can we have some discussions, or we can have the discussions after Dr. Thomas speaks?
Because the idea is we have the data now.
Now we need a user who uses the data. That's why Thomas comes into picture. So after that, we'll open the floor for discussion so that we can do the one.
Yeah, may I now request Dr. Thomas Heege to take over the floor and then give his views. Dr. Thomas?
Yeah, thank you very much for this discussion here. So I will make also a small invention. Then actually, yes, I will try to make it a little bit application from the application point of view. Let's see if my presentation is running in the presentation mode. Do you see my screen?
Yes, we can see it.
Yes, okay. So I will address some applications with satellite-based assessments, with focus on suspended matter in inland waters and waterways. And first of all, to summarize, there's a lot of room for Earth observation data services to support environmental topics for river monitoring. It is impact assessment, it is environmental monitoring, it is the whole planning process also of water industries. It is even inland water navigation support, so increased safety here, dredge monitoring. So there's a lot of topics, and I will address a few of them off the background then here, what we can do nowadays with satellite data. As it was already mentioned, we have an increasing number of satellites available. Every year we have more satellite records available. Of course, not every satellite, Earth observation satellite, delivers resolutions that we can use in river systems and in inland waters. You see here MODIS 500 meter and an example here of Rio Doce in Brazil, which gives just for few large rivers, of course, some data, but nowadays with Landsat, Sentinel-2 and the very high resolution data, we have a quite good base of information. It is data, it is still not information because it only comes to information after we do data analysis processes, so which we are specialized on here at EOMAP, and deliver these data in the frame of the different applications, which I will address later. So nowadays, we have over any location worldwide yearly, something depending which resolution we are looking at, after maybe 200 to 1,000 records per year and per location, which is quite a lot. Of course, not all, then maybe in the highest resolution, but already covering a lot of river networks globally. One simple application where we have both the requirement to understand the river network and what happens in the transport processes in relation to a relevant application. That's the hydropower sector. You see here an example of one of our clients, which we serve regular since 2 years, up to daily, with actual information over the whole dam and river network around the dam. So that's here the Cahora Bassa Dam in Mozambique. It's the largest dam in this country, so it has quite a huge economic importance in that country. And you see on this one example, on the left-hand side, you see the rivers where the water is entering, the different river sources which enter the basin carry very different loads of suspended matter in this image, colorized with this river coming from the north, carrying almost 500 or more than 500 milligrams per liter at usually in January, and other rivers which bring a significantly reduced load. And you see still following this, the impact of this river goes over half of the basin, which is quite very long distance. The actual information which is required is the turbidity and suspended matter information, and together with other parameters. And you see here, we deliver these data on a web application. So these are measurements over the last year. So quite a lot of measurements are available nowadays and easy accessible, and then supporting the directive processes of the Cahora Bassa hydropower company, and also support the decision processes here to better manage the reservoir, because sediment is a major cost driver of the whole system there. I will not go to the details, but another example also related with hydropower, where Earth observation can serve in the planning phase already. When you want to develop a country, want to install new hydropower plants, you first have to analyze, of course, the river network, the whole hydrological data which are available usually are so there's usually very rare data available hydrological. And here both the water flow plus the sediments are the critical parameters. And with remote sensing, you can simply measure them in the past and nowadays in order to do the right analysis where it makes sense to install a hydropower application, or then calculate related costs with this. So that's one example where a whole country, or a smaller country in this case, can be supported, but it can be in the same way a larger country. You see here for India, we supported the Water Resources Institute over different areas with river sediments, different products, river sediments, organic loads, in order to do environmental assessments as well. So there's a range of topics, and it is not only water quality and sediments which can be measured, also morphology can be measured within rivers and also coastal zones. You see here one example from a client, the Water Authority, Water Construction Authority, which we support since several years, also regularly with the morphology changes. That means these data provide, even if the water is too turbid to calculate water depth directly from the satellite, which we can only do in transparent waters, we can derive here through the frequency of the water coverage, then the intertidal areas and the morphology. Same would apply for rivers. Dredging applications are one topic which nowadays we usually do for offshore industries, but it could be a topic also in future for inland waters. So just to summarize, routine water and regulatory monitoring is an issue and is an application that supports a range of different clients already. Dredge monitoring, currently in Earth observation, we serve to offshore industry clients, but could be served also to river authorities. Disaster is, of course, one important point. So like huge disasters like the Rio Doce disaster a few years ago, back in Brazil, since that time we are supporting one large environmental company in Brazil with regular water quality assessments, and even train them to do it themselves. Impact monitoring is one topic, hydropower, I mentioned all this. Using such data is not just bringing data, giving the clients or users access to data. It is as well how to prepare such data for clients, for example, in form of river transects, because it's much easier than to understand what you want, what you're looking for, or not to provide the full resolution images is frequently not helpful. To aggregate in space and time the data then in a way that makes it possible for the clients to draw the right conclusions, to make it ready for a decision. Last note I would like to draft is that increasingly organizations want to have their own to use satellites as own measurement instrument. And we see this is possible nowadays as we can provide the access to the satellite data plus to the data analytics in an easier ways through web portals. So that means clients can and users can say, I need in this location, I need data, I need them aggregated in a certain form. Press a button and get this back delivered. So we have developed such solutions, and this is an ongoing topic nowadays to empower users. So empowering use this capability on their own. Of course, the requirement is a very good data analytical method behind that. That's what we are supporting because the value of the data comes with the right quality and the right temporal and spatial resolution. That's where we started in the beginning with the satellites that we have nowadays, which gives really excellent value and excellent new tools for this application. I'm happy for this. I'm looking forward to the discussion. Thank you.
Thank you very much, Dr. Heege. So now we can move on to the discussions and open the floor for the participants. Before we go on, I will start the discussions first from Professor Strunz. Professor Strunz, I have a very quick, I need a very quick input from you. As far as storms are concerned, what kind of monitoring can be done? What kind of can it be real time, and what kind of data we can get from the cooperation, from the international cooperation?
Yeah. So, So as I said, in case of its charter mechanism, a governmental organization can activate this in case of a disaster. So, but after the activation of a mechanism, this information is provided to the user, to the authorized user. And normally this information is also open and freely accessible to the public. Only sometimes this information is restricted.
Yeah, when we say information, what is this information? What kind of information is this?
The information is about the flooded areas. So that's the information, which part is flooded, which is the normal extent of the water, and which is the flooded area. And because we now have so many, so frequent revisit times, we can also provide information about the flood duration. So this is also very important information because of the consequences of a flooding event. It's important how long the flooding lasts. So for instance, how long are the agricultural areas flooded? And this is extremely important. This is also an information which can be provided.
So when we say flooded area, this happens post-event, am I right? So is there any information that we can provide which can happen before the flooding happens, which will help in planning the evacuation or managing the disaster that is likely to occur in the next 24 hours or next 6 hours or next 12 hours, something like that?
Yeah, this is the other aspect. On the one hand side is the emergency response aspect, so providing information as soon as possible in case of an emergency to deal with the emergency. And the other thing is, because we now have really this archive of satellite data already available, we can go back, we can reprocess the data, and that gives us information about the flood risk. Because if we process, for instance, the data from Sentinel-1, we can go back 6 to 7 years. If we also process other data from the many ISRO missions or the Landsat mission, we can also provide information about flooded areas during the last 10, 20, 30 years. And this gives us information about the flood risk. So emergency response, very time critical information, and flood risk we can get by reprocessing of data and looking into the archives.
So reprocessing, sorry, this question is a little bit longer. I'm sorry about that. Reprocessing the data is something that can happen during calm time. So we can do it much earlier than the event that is likely to occur.
Exactly.
So it will be in a slower pace. So do you still need the activation by the government to do this kind of a cooperation, or what?
This reprocessing is not part of an international charter, but as I showed you in my last slide, this new idea of global flood mapping, here reprocessing is also part of this activity.
Okay, so we can set up cooperations which can work on the reprocessing and then understanding what has gone in the past and how things are likely to happen in the future,
Exactly.
etc.?
Exactly. So as I said, we will do it globally using Sentinel-1 data. We could also, in a cooperation, also think about including data from the Indian Earth observation satellites and provide or include more data to do this kind of reprocessing and risk assessment. Yes, yes.
Okay, thanks very much. That's great. My next question is, I will make it very short, is to Thomas. Thomas, we talked about, I mean, you displayed one slide on dredging monitoring. I think it's mostly useful for capital dredging, isn't it, rather than maintenance dredging?
Usually we do this for environmental assessments.
For environmental assessment,
Yes,
I think when we say monitoring of the dredging, this is something that happens during the dredging exercise. So
yes,
to monitor how the environment is getting affected, whether they are within the limits or not. So to monitor this. So I mean, is this data commonly available? If it is commonly available, there is an exercise going on in India now to make a guideline for dredging activities. So it's possible for us to include a satellite-based monitoring as a part of the dredging guidelines. If all of us think that it is something that can happen commonly.
That's correct. It is even the case that the first of this dredging monitoring, the commercial dredging monitoring project that we run 13 years ago, it happened that the regulator took up this information and then drafted a new regulation requesting for spatial information on sediments to be delivered.
So this is the part of the European regulation, or is it?
No, this was in Australia. The Australian regulation.
This was in Australia. Okay, thanks very much. So I am done with that. Now the floor is open for other participants. I'm sorry, Fritz, I can see your smile. So go ahead. Go ahead. We can take the discussions one after the other. You can simply raise. We can all see you, so you can simply raise your hand physically, or you can maybe do it in the chat window. Is it okay, Dr. Raju, or we do it by invitation?
I prefer that they can come up with questions. Actually, there are many, they were asking about satellite data and all. So I think I brought in the right person now. So
okay,
especially the data is free, very important. Try to use this opportunity. We are data hungry people.
Okay. Shall we start from Daniel then?
Daniel Rosado or?
Sorry.
Yeah,
You meant,
go ahead.
well, I wouldn't like to take the time of the students, and since they have, for example, I see Elias have the rise up, so maybe we can start with them.
Yeah, Elias, go ahead. Sorry, I didn't notice that.
Yeah, hello. Am I audible?
Yeah, you are. Go ahead.
Okay, great. Well, I have a question regarding the satellite technologies. I'm not really connected to inland water transport, but yeah, at first, thank you for the very interesting presentations. And I have the question, so since Elon Musk is sending a lot of small satellites into space, and there are different issues connected with that. So for example, that stars cannot be observed anymore, or for example, that the night sky will not be seeable again. So I wondered, and also there are different aspects also on the possible coalitions of those satellites. And I was wondering what actions are being taken to prevent possible coalitions of different satellites into space, and how the communication is up there.
I don't know, this question can be answered by Professor Strunz.
Yes, I will try. I mean, this is really a very important topic. This is space situation assessment. And this is a very, very critical and very important topic. And in Europe, the European Space Agency has is dealing with this topic, and of course NASA and all the space agencies are acting on that. So we have monitoring systems where we observe, I would say, several thousand parts which are in the orbit, and they are observed. So you can predict the orbit, and in case these small parts could affect a satellite or even the International Space Station, then some maneuvers are being taken in order to avoid a collision. So this is already done. This is operational. This is an operational task. And as I said, so several thousands or 10,000s of objects are already monitored. These are the objects which are the bigger ones. But the big problem is the very small ones, because you cannot monitor them. There are millions of these very small parts in orbit. And so there is still a danger, and there's a critical situation sometimes in orbit. But as I said, the space agencies have realized this problem, and they are very active doing on that. And yeah, so a lot of research activities are also going on.
Thank you.
To add on to Prof. Gunther, there is a space debris monitoring project by NASA. You can check the websites as well. So they are trying to pick up those unwanted satellites which are, after completing their cycle, they have been picked up by the major ones, and also including like sky laboratories, space laboratories. All those things are being picked up as a debris, and also this space debris disposal also they are taking into consideration how to dispose them also. This is one of the important activity. It is in the website as well of NASA. Thank you.
Yeah, and the same in Europe, as I said, with ESA, and we have the same.
Thank you.
Okay.
Yeah, there is one in chat box. Can I read it out?
Yeah, please read it. Okay.
I know. Yeah. Yes. Can you tell? Yeah, please.
Yes. Yeah. Thank you, Professor and Thomas, for the nice presentation. I really enjoy it. But a little bit confused on remote sensing data. I guess you used remote sensing data to and artificial intelligence for flood prediction. I mean, based on the satellite data. You develop some a model using an artificial intelligence, and you are going to predict or something. I'm a little bit confused on this. If possible, I need clarification. Thank you.
Yeah, so we do not predict these things. So this is not what we are doing. This is part of a modeling. But what we are doing is, first of all, we have developed our algorithms based on physical models where we derive the flooded areas from the satellite data. So the physical model behind is that the radar signals are reflected in a different way if they are on the land surface or if they are on the water surface. And this is used in our physical models to derive the flooded areas. And now with the new convolutional neural networks, we can now use these data, these flood maps, which we have already created, to train these neural networks. And then we can do the same with a neural network, what we currently do with our rule-based methods. And the big advantage of this neural network approaches is that they are much faster. So that's a big advantage that we currently see, and the accuracy and the quality is very similar.
Okay. Does that answer your confusion? I knew. Yeah.
Yeah, I was what I expect, because we have information about the flood extent from the satellite data. So Professor and Thomas used this satellite data, and they are going to predict the flood. that was my expectation, but now it's clear. Thank you so much.
Great, thank you very much. Who is next? Any further discussions? So by the time the others are thinking, Professor Strunz, I just wanted to know, so from the Indian side, it's only the ISRO which activates the international charter, am I right?
So ISRO is the member of a charter, and they can activate the charter, but it's also the National Civil Protection who can activate the charter. Yeah.
So the National Civil Protection can directly get in touch with you and ask you to activate the charter.
Exactly. Yeah.
Okay. Great. I wanted to ask you, I mean, what were the actual disasters that we were considering? You answered that in one of the slides, so thank you very much. But I was also thinking about, you also talked about slow processes, slowly evolving disasters, such as environmental disasters, which will happen over years and decades. Are there programs which are aimed at understanding this at an international level, or can we formulate new programs like this which can focus on understanding disasters in certain regions?
Yeah, well, as I said, these low onset disasters are not covered by the International Charter on Space and Major Disasters. But of course, there are other programs which are, for instance, doing a drought monitoring. So, for instance, UN organizations like FAO or the World Food Programme are doing very much on that topic, on these low onset disasters, because it has high relevance for food security.
So it's possible that we can develop such programs with international or international cooperation, and then it can go on a research mode based on funding from various agencies. That's possible, isn't it?
Yes, we are open for such cooperations. Yeah.
Okay. Are there any interactions from the students?
Maybe in line with that, Professor Murali, just I'll complete in line with that. We had a cooperation with DLR, German Space Agency, on land subsidence, sea level rise and land subsidence. This is very important for Singapore. And that is where we wanted to know how much is the land subsidence against measuring the sea level rise. So they have the sensor, which is the synthetic aperture radar, which can able to provide time series, multi-dated satellite data, which can able to provide how much is the levels, which are measured during period of time, like 10 years, 15 years, 25 years. What is the amount of land subsidence? And this we can correlate with the sea level rise factors.
Okay, great. Are there any other discussions? If not, I will have a question to Thomas. Okay, Thomas, I'll share my screen, then I will ask. You are able to see this?
Yeah, thank you. Yes, I see this.
This is one of the stretch of Hooghly River, and there is shipping taking place in this river, like you have shipping in European rivers. And I can point out this region where you can see a dark patch. Presumably it's a shoal. And also this line is likely to be the deeper channel where the vessels will navigate. So my question was, I mean, with respect to inland water transport, these two questions will keep coming to us again and again. One, what will be the dynamics of this shoal in the past? What has been the dynamics and what will happen in the future? The second thing is, where is likely to be the deeper channel? Can we answer these questions from your products and or your expertise?
Yeah, thank you for this question. I think it's the right question here for the remote sensing contribution. And I think actually the shoals mapping at least for larger rivers, as we say here, can really be addressed systematically with remote sensing. So I'm quite sure that we need here to implement in such a process many satellite images, so just to reduce error. So, and you will see in the upcoming weeks, maybe it's even already published, that we delivered such a shoal atlas in the sea. Of course, it's different, but it is a very similar approach that I would expect feasible here for the rivers, larger rivers in India as well. So, so the answer is yes, it makes absolutely sense. Also, as we discussed earlier already, to try to systematically map these. So maybe first in a demonstration project covering certain river section, but then it could be, I think, operationalized to deliver a regular update, maybe a quarterly update of shoals to improve here the safety for navigation. I think that's actually quite feasible.
When we say shoals, are we talking about only shoals which are visible above the water, or those which are completely under the water?
I'm talking as well to shoals which are completely underwater, but they have still to be visible. So it can be either to resuspension processes, because usually the flow speed changes over shoals, and also the resuspension processes. That's why they become visible. They don't become visible because we see them at high background concentrations of suspended matter, but they become visible because of these resuspension processes. And they stay, of course, stable for a certain time at the same location. And that's why with multiple satellite imagery and continuous recordings, I think we can follow the movement of those shoals. I don't expect that we can cover all shoals, so it depends on the depth, of course. If they are then 10 meters below the water surface, then it's too much, but then maybe it's already above what we need to have, then depending on the ships that are
okay.
Yeah.
Okay, thank you very much. And there is some discussion.
Yeah, from
there is a question from Anthony Noronha. Can you read it, Dr. Raju?
Yeah. Thank you for the wonderful insights. How can we implement machine learning, AI techniques coupled with remote sensing into the day-to-day IWT, say for example in the Kiel Canal? What do you think can be adopted as the best practices in this domain in the near future?
Okay, so maybe I can answer to that. Well, what I showed, the artificial intelligence approaches are, of course, still research and development, because DLR, we are a research organization and we are developing these methods. And of course, we are trying to apply that in different projects and applications. And in case of your application, we would need a bit more time to talk about that. So I'm very open. You can approach me after the session where we can discuss a bit more about this. What are the possibilities and what are also the limitations? Because it's very clear what I showed you, this free and open data. These are not the very high resolution data. So these are data with a resolution of 10 to 20 meters. So they are perfectly for a global mapping. But they might be too low resolution for a very detailed mapping. So all these questions have to be discussed in more detail, I would say. But as I said, I'm open for such a discussion. And as I also said, these approaches using convolutional and neural networks and artificial intelligence are still research activities, but very promising, I have to say.
Okay, great. Any further questions from or interactions from the participants? So, Dr. Raju, if there are no further interactions, can we thank the experts?
There is one, I think. Assuming, yeah, please.
I have a question regarding early warning systems. Do you think it can be it can be applied to this extreme climate change and this extreme disaster prediction? And how long is the window to early warning? Like how long in advance? Because I have learned recent weeks this snowstorm in Texas in the US, it caused very much losses. Do you think that how to say can be detected by this early warning system? And if so, like does it really work for that? Do you have any data or information regarding that?
I'm not sure if I understood you correctly because the connection was not so good. So again, what we don't do, and we are not the experts on that, but this would be other scientists, we do not the prediction. So we really document what is happening and what is the current situation. And of course, we try to do this more and more in close to near real time, but we are not doing prediction.
Yeah, can I supplement that, Professor Strunz?
Yes.
Yeah. Zooming as a domain expert, I work a lot on cyclones and prediction of disasters by cyclones and other coastal disasters. If like Professor Strunz was indicating, if we can dig through the archives using various techniques and data mining and artificial intelligence, etc., and create a database of the past events and the corresponding disasters, flooded areas, people who have been affected, and what services were affected, things like that. It's really possible to do this in real time, like Professor Strunz was indicating. So it can be, we can do it in real time, or we can also predict things that are likely to happen tomorrow, today, or maybe 24 hours, 72 hours in advance. It's possible to do that. So are there any further discussions? Dr. Raju in the chat window?
Nothing as of now.
Okay.
I would have a question, more specific, but I'm curious about how could you interpret or how can you evaluate the aftermath of an earthquake? Is it that you would evaluate the destruction of land surface or landscape?
So in case of an earthquake, we do the mapping of the damages. So we typically use very high resolution data because this must be very detailed and very high resolution, and we are estimating damages in the ideal case of individual buildings, but normally we do the damages on a block level to get an overview. And what is also very important, we provide information about the infrastructure, because this is very important in case of an earthquake emergency. You must know which bridges are destroyed, which roads can be used, and we also provide information about, for instance, critical infrastructures like the hospitals and so on, or even find places which are open spaces where the relief organizations can build up some tents or something like that. So it's more providing information to the early responders. And also sometimes earthquakes are also interrelated with landslides. So we have, for instance, as a consequence of an earthquake, we have landslides which are blocking roads, and this is also very relevant.
Okay.
Okay, thank you, and thank you for the presentation.
Okay, so Professor Strunz and Dr. Heege, there were many messages in the chat window that have appreciated your presentation and your area of work. And I'd like to thank on behalf of everyone for your wonderful presentation and your time here to share your thoughts and your knowledge with the younger generation. We once again would like to thank you very much, and we wish that your good work will continue, and we see you some other time in a different mode. Thank you very much.
Thank you. Thank you all.
Thank you.
Thank you all for this.
Thank you. It was a pleasure.
Thank you.
Thanks a lot. Great.
Thank you. Thank you.
Bye.
Yeah.
Goodbye.
Bye. Bye.
Bye-bye. Thanks.
Yeah.
Thank you for your presentations.
Thank you. Thank you, Daniel. Thank you.
Bye-bye.
Bye-bye.
Bye. Thanks. We can close the session, Dr. Raju?
Yeah, I think Lisa will take over, I think, if I'm correct.
Sure.
I will
Okay.
stop the recording.